Hi everyone, and welcome to World Maths Day. Today I'm going to teach you about one of my favourite areas of maths, which is binary numbers. Now, binary is a code that's made up of zeros and ones, and it's used a lot, particularly by computers, to communicate information. Let's start by comparing it to our number system. So in our number system that we use every day, there are 10 different digits that we can use. We've got everything from 0 to 9. So we call that a base 10 number system because there are 10 different possible digits that we can use, and we combine them in different ways to make bigger numbers. So what would we call these number systems? So if we had a number system that used the digits 0 to 7, what might we call that? Or if they just use 0 to 3? Or if they just use 0 and 1? Pause the video to think about your answer. Let's have a look. So using the digits 0 to 7 would be called a base 8 system because there are 8 different digits that we can choose from. So it only goes up to 7, but remember we've got 0 as well. This middle one here, we've got 4 different digits that we can use. So we would call that a base 4 number system. And then just using zeros and ones, like binary, is called a base 2 system because there are only 2 different digits that we can use, but we can still make any number in the whole universe. To make larger numbers in a base 10 number system, we use the place value columns ones, tens, and hundreds to help us build up to bigger numbers. And obviously then we go beyond that to thousands, 10,000s, etc. In a base 2 number system, you move up much quicker because you've only got 2 possible digits you can use. So the place value grid looks a little bit different. So we still have ones here, but then we have 2s, 4s, and 8s. And again, it goes up much bigger, which I'll show you in a second. But can you notice the pattern that's happening as we move up the place value columns? What's happening to the numbers? Well, they're doubling. Double 1 is 2, double 2 is 4, double 4 is 8. So what do you think the next place value column would be? It's 16. And actually it goes up really quickly, as I said. So we've got 16 as the next one, then 32, 64, 128, and it just keeps doubling and keeps doubling. And we can use just zeros and ones to make our numbers. I'll show you. So if we wanted to make the number 1, well, that's easy. We have a ones column, so we just put 1 in there. But if we want to make 2, we can't just put a 2 in our ones column. We don't have any 2s. We only have zeros and ones. But that's why the next column is a 2 column. So we've got 1, 2. And have we got any 1s? We don't need any. We've already got 2 there. So 2 in binary is shown as 1, 0 because you've got 1, 2 and no 1s. If we wanted the number 3, we don't have a 3 in our next column. So we need a 2. And we also need a 1. So if we've got 1, 2 and 1, 1, that gives us 3. What do you think the number 4 would look like? Pause the video to work it out. Well, luckily 4 is quite simple because we've got a column with the 4 label on it. So we've got one of those. But we can't just leave that on its own. Binary is a bit like our base 10 number system in that way, in that all the columns on the other side must have a 0 on them. So we must have 0 there and a 0 there to show that we have no 2s and no 1s. We've just got a 4. So there we go. Have a little practice if you want by pausing the video and counting up. See if you can get to 10. Did you get there? It's easy once you know how, but it does seem tricky to start with. So let's have a look. If we've got 9 in base 10, we can just use the digit 9. But what would it be in binary? Well, we haven't got a 9 column. The biggest we've got before that is an 8. So let's put an 8 in there. And how many more do we need to make 9? Well, we only need one more. So let's put a 1 in our ones column. So we've got an 8 and a 1, and that gives us 9. But of course, we've got this gap in the middle, so we need to put some zeros in there. And there we are. 9 in binary is 1001. We don't call it 1001 because, of course, remember this 1 isn't a thousands number, it's an 8. So we call it 1001. Pause the video and see if you can work out what 14 would be in binary. Think you know? Okay, let's check. So again, 14, we don't have a 14 column. The biggest we can use is 8 because 16 is too big. So we put a 1 into our 8 column and we need 6 more. So, well, the next one we can do is a 4. So let's do 4. So 8 and 4, we've got 12 so far. We need 2 more. Ah, well, there's a 2 column. So 8 add 4 add 2 gives us 14. And we don't want any ones, so we just put a 0 there. So 14 in binary would be 1110. Okay, we're going bigger now. 85. Pause the video to try and work out what 85 might be in binary numbers. Let's see. Well, if we put a 1 in the biggest one we can, that's 64, because 128 is too big. That takes out a large chunk of our 85 already. So where can we put our next one? Can we put it here? No, because 64 and 32 put together would make 96. That's too many. Let's put it here. 64 add 16 is 80. That's okay. We're not up to 85 yet. We just need 5 more. So not an 8, that's too many. 4 there. And a 1, there we go. That would do it. 64 and 16 is 80, add 4 is 84, add 1 is 85. So we've got our 85, and then we just put zeros in the gaps. Oh, there we go, it makes a good pattern. So 85 in binary would be 1010101. Well done if you got that. So let's look at reading binary numbers. So here I've got some binary numbers for you, and we've got to try and work out what those numbers are in base 10 in our normal number system that we use every day. So let's start by putting the first one into our grid. We have 101. Well, all we need to do is find the columns with the 1 and add them together. So we've got a 4 and a 1. 4 and 1 gives us 5. Okay, let's look at this one, a little bit bigger, 11001. There we go. So pause the video and work out what that is in our base 10 number system. Well, if we add the columns together, we've got a 16, an 8 and a 1. So 16, 8 and 1 added together make 25. Okay, this last one. 1010110. There you are. So again, just add up the columns that have the 1s in. Pause the video to work out what this number is. It's 86. So it's very similar to the 1010101 that we had before, which was 85. Now it's your turn on your own. So draw yourself a place value grid like this if you haven't already, with the right column names at the top, and then just put in the numbers here. So 1, 0, 0, 0, 1, 1. Well, there are 6 digits there. So 1, 2, 3, 4, 5, 6. The first one's going to be in your 32 column. So work out each of these and what we would call them in base 10. So what are they in our usual number system? Pause the video to have a go. Right, let's have a look at the answers. There we are. So this one here is the number 35. This one is 55 because we add all of these numbers together. And this one here is 125. And you end up with quite a long number to represent a fairly small number in our number system. But that's because we've only got 2 digits to work with. Why not have a go at investigating these things in binary? So what would your age be in binary code? And what's your favourite number in binary? Your shoe size? Your oldest relative's age? And the number of people in your class? Work out what all of those would be in binary code. You can even investigate much bigger numbers if you're really brave. And I've added an extra bit at the bottom to suggest that you look up your favourite times table and work out what the numbers would be in binary. Is there a pattern to them at all? Just keep investigating and get more and more confident with the binary number system. One day I might even teach you how to write coded messages in binary. But for today, we'll leave it there. I'll see you tomorrow.